Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. We just finished yesterday doing a an upgrade to multi render target rendering. We had sort of went through a couple tranches of doing it. First, we supported it in the render stuff, then we supported it in our software render, then we supported it in our hardware renderer, and we're basically done with that now. And so at this point, we're ready to kind of go back and start working on our Z path stuff. But I was thinking today, since now is kind of a good stopping point a little bit, I was thinking of going back here and just cleaning out some of the bugs that we have that are just like typos in places or things that we didn't quite do correctly for whatever reason that we know we didn't do correctly, but we haven't gone around to actually look at. And so I appreciate, by the way, anyone, if you've pre-ordered the game, there on your Sendowl download page where you can download stuff, there is a code you can use and some instructions on that page. You can go look for it if you didn't know already. There's instructions there about how to get on the private GitHub, and that's what I'm on right here. And a lot of people asked for that, so I did the work of actually supporting it, and it's there, and it's updated nightly, so it's synced. It's always up to date. If you go on there, if you notice a typo or a bug, you can report it, and it's pretty handy because then we have this little list that we can look at, so that's kind of a nice feature. I don't really use the GitHub for anything, but I do like having the little bug list. I think that's pretty handy. So if you want to report one, you can always do it there. If you didn't know about the private repo, you do now. And if you pre-ordered, you have access to it already. You just need to go use your code to authorize whatever your GitHub username is. So here's a bunch of stuff we've got, and I'm just going to kind of go through these and see like which ones of them I think we could fix and which ones of them I think we might need to leave open, right? All right. So let's start with wrong GL viewport parameters, and we've got two problems here. So what happens here, I believe, is that we sort of have a we have this notion of what size things are, and you know, we're talking about what size we were rendering to originally, but then we sort of were using the wrong thing. Like commands width and commands height is the size that we're going to talk about in terms of pixels, but we don't, when we're using OpenGL, it's free for us to just stretch things out to the whole size of the screen. So it seems rather logical to just always use however big the window is, right? So we could do that, and that's what they're suggesting here. Now, there's a problem with this approach, however, which is what happens when the screen is not the same aspect ratio as what we're rendering. So we kind of need to actually do a little bit more here to fix this bug, but that's okay today. That's something we can totally do, which is to say we'd like to have you know, put black bars on the screen or something if we're running in something other than a 16:9 display, right? We'd like to be able to make it so that it was centered in the window, not stretched and warped in a bad way. So let's go ahead and start here. Today is day 322, so I am starting with the day 321 source code here. That's what I'll be working with, so if you want to follow along at home, please go ahead and grab that code. Let me go ahead and also just make sure we're running properly and everything's good here. Yes, so I think we're all good. Everything seems to be running pleasantly and no problems. So if, and I suppose the other thing I can sort of do is say, well, okay, if I was to run this here with a different size window and like this, you know, we could sort of make it so that this worked better. Like, so for example, you can see here as I'm changing the size of the window, all it's doing is cropping. And that's, you know, we could call it a bug, we could call it a feature, I don't know what you want to call it. I'm inclined to agree with this bug and say it's a bug. So what we'd like to do is make it so that we use that window width and fit there. But as I said, this is going to cause some warping. So let's take a look at what happens when I do that, and then I'll sort of show you how we can, you know, why it happened, and we'll kind of go into it into a little more detail. So I don't think we set the viewport anywhere in here. Yeah, I think we only set it over here. Right? Yeah. And so if you take a look here when we do OpenGL display bitmap, you can see here that, when we do display bitmap, that's the one, this is the path we use when we are going to do our, when we're blitting our software into the screen. But you can see here that, yes, we would like to take the window width and the window height, and we'd like to draw to all of it, right? So if it's smaller than what we drew, we want to shrink, and if it's bigger, we want to expand, right? And the same thing would be true when we do our GL viewport here for our OpenGL render commands. When we do our viewport here, we would like to do the same thing. Make sure that we actually are drawing to just however big the window width and window height actually are. Now, we do have a sort of problem with that, which is that if we're doing that, we have to then sort of continue down all the way through and say that instead of using commands width and commands height for our render targets now, we're also going to have to use window width and window height for those targets, right? Because we're drawing, we have to make sure that everything lines up for all of our render targets, right? So that's just kind of a requirement that we would have to have there, unless we take some other sort of steps later to make sure that things go okay. So there's kind of two ways that we could do it. We'll do it this way at first, and then we'll kind of go from there, right? All right. So if we go ahead and look at what happens now, you can kind of see the problem that I was trying to describe before. A picture's always worth 1,000 words, so my description of it probably wasn't that clear, but hopefully you can now see what I'm talking about. If I shrink the window down to this size, probably the person doesn't want to play this game, right? That is not what they were trying to see. They didn't want, a super tall, super skinny version of the game when they sized it this way, probably. Nor did they want a long, smushy version, if they're going the other way. And, the way that we've got it now, it looks like our picking's also off when we do that, so we should probably go test fix that as well, but that's a separate issue. Anyway, I don't really know what, it's this one, right? Yeah. You can see that we still match in both cases, so that's, like I said, that's that GL viewport call, since we did it in both cases. When we switch to the software render, we get the same warping, which is good. We want to be the same in both cases, but what we'd like to do is do something better than what we're getting here in both cases. All right. So let's start, if we can. Let's start by talking about the problem on the blackboard a little bit, just so you can understand what's actually going on if you're unfamiliar with this, and then we can go ahead and come up with a fix for it. So here we are on day 322, and this is aspect ratio. Oops, not ratio resize. And I can't remember, we may have already covered this. I can't quite remember. When we do our display buffer to window, so it doesn't look like we always split 1-to-1 here, so we didn't really address this ever. Here it is, so there's the to-do. Centering black bars, okay. Just wanted to make sure I wasn't telling you something that you already knew if you watched the series. Okay, so here's our basic problem. We have a number of things as game developers that we can choose to do with respect to supporting multiple monitor size. Some of them are much harder than others, and we're going to take a kind of a middle ground with Handmade Hero, and we're not going to go too far down the rat hole, but I'm going to at least tell you sort of what those tranches are. So one way is no aspect ratio support. Right? One way is sort of like black bar, and another way is like, actual, I guess, aspect aware, I guess we'll call it. And I'll briefly talk about what these are. So the simplest thing to do, obviously, is just not support different aspect ratios, right? And what do I mean by that? Well, what I mean by that is, let's say you made the game and you made it at 1920 by 1080, right? That's what you did. So you decided that's the resolution I'm running my game at. That has an aspect ratio, right? And, you know, if you've never heard of aspect ratio before, it's probably you have, because even if you don't program, you probably heard of aspect ratio. Aspect ratio is just talking about how long one side of the monitor is to how long the other side is, right? And so typically a 1920 by 1080 or HD TV sort of aspect ratio is 16 on the long side by 9 on the short side, right? So we typically call this a 16 by 9 aspect ratio. And you can kind of see that that's, you know, a standard 1080p television, whatever is going to be that as a standard. It's a common thing to be. It's what a lot of monitors are, although there are plenty of other ones like 16 by 10 and whatever else. Okay. So one way is to just not have aspect ratio support. Let the monitor figure it out. Just don't deal with it. And what that tends to look like in practice in a game is there's a Windows call called Change Display Settings. And what it does is it basically allows you to just straight up change the display's resolution to what you wanted it to be, right? So what you do here is you pass, let's see, where is it? Gotta hunt through for it. Here we go. You pass a certain Pell's width and Pell's height, which is the height and width of the screen in pixels, and you just say, Windows, this is the display resolution I want, and you're going to have to figure out a way to get it, right? So we would just call that with 1920 by 1080 and be like, good luck, and then the monitor will do whatever the monitor will do. So the monitor gets a signal at 1920 by 1080. Hopefully the monitor supports it. If it doesn't, you're totally... you know, the game won't even run, right? It'll just show a screen where the monitor just comes up with a thing that says, like, unrecognized video signal or something, right? But if the monitor's native resolution isn't that, if the monitor is 16 by 10, say, instead of 16 by 9, it will figure out something to do. Who knows? Maybe it'll stretch. Maybe it'll put black bars on the top and the bottom. Who knows what it'll do, right? But the point is, you could choose to have no aspect ratio support in the game whatsoever if you wanted to, and plenty of games actually do that. They just set a resolution, and they just expect you to have a monitor that will cope with it, and that's it, right? So we're not going to do that one. Okay, we're going to try to do a little bit better than that one. We're going to shoot for black bar, and we'll talk about that one in a second, but then let me talk about this one first, since it's another one that we're not going to do. Aspect-aware games are games which try to put a bunch of logic into the game to allow you to play it at any conceivable aspect ratio, right? Now, this is very difficult to do with a 2D game like ours, which is why I'm not going to do it. It's not particularly difficult with certain types of games. For example, first-person shooters are actually quite simple to make aspect aware. Now, it may not be so easy to guarantee a fair multiplayer experience because the FOV is going to change and there's going to be a bunch of like sort of other things, but at least as far as a single-player first-person game, making it aspect aware is actually pretty easy. Now, why is that? Well, what does aspect aware mean? Well, aspect aware means that, you know, I've got a game, and maybe the game runs on a screen that looks like this, or maybe the game runs on a screen that's a little bit wider and there's extra room, or maybe even a little wider than that, right? Or maybe it's on a screen that's like taller, right? And who knows, right? And again, we're specifically talking about aspect ratio here, not resolution, because they're two different things, right? One is about, you know, if it's just resolution, we can just scale. If the aspect ratio is the same, we can just scale our bitmaps up or down. And yeah, maybe they look a little blurrier because we had to do that, but we can accommodate that pretty well. But the fundamental aspect ratio is like the shape of what we're drawing, right? Whether it's wide or not, and that has implications. Hopefully you can understand why that has implications. But anyway, for a 3D game, for a 3D like first-person shooter, not a 3D game. If it was a 3D game that was just like ours, you'd still have the same problem. So it's really not 3D or 2D. It's more about the sort of type of game. But for an FPS, right, All you really need to know is that, well, there's a gun in the corner, so we have to kind of put that gun in the corner, right? And then there's maybe like a health bar up here, so we need to just put that health thing in the corner. But then otherwise, we just render the scene with whatever our like view frustra actually is, and we're done, right? So in order to make a simple first-person shooter aspect ratio aware, it's not that hard. You just have to know where the corners of the screen are and sort of like correctly place a few special items, and now you're done. So making an aspect ratio aware one of those is not particularly difficult, right? The design of the game doesn't really change that dramatically. Again, for a simple first-person shooter. You could imagine first-person shooters that maybe had a lot to do with the screen size, so you can't say for all. It's not true for all game designs. But for certainly something like Quake Arena, let's say, you could totally do this. But for a game like ours, we don't really have that ability, and the reason for that is we're kind of counting on a particular room shape. And we need you to be able to see that whole room, right? And that room needs to be on the screen the whole time for gameplay reasons. So there really is no way to make our game aspect ratio aware without I mean, it might not even be feasible, right, to do. It may literally not be able to do the design that I have, may not simply work, aspect ratio aware. So, because since you know you need to see this thing and that is the shape, there's really nothing you can do about that. All you can do is just maybe, like, pad out by putting some extra UI on some, you could try to maybe decorate it a little bit, but fundamentally speaking, you're going to have to show that aspect ratio image somewhere on the screen, and you're going to be left with empty space if that's not the shape of the monitor, right? Which is a problem you don't have in this circumstance. So that's why I'm not going to do that one. What I'm going to do is basically the middle ground here, which is sort of black bar aspect ratio aware, which is to say that we will ensure that you get a reasonable, crisp image centered and stretched appropriately so that it fills your monitor as much as it can given the aspect ratio that you have and that we need, right? So what that entails is saying, well, okay, we know that we need to draw a 16 by 9 image. So if your monitor is actually 16 by 10, we will figure that out. We will draw the image here, right? And then we'll fill this in here and here with black so that you don't see it, right? So that it's like minimally invasive, just like a letterbox home movie, right? And again, the reason I think it's better for us to do that than to call change display settings and have the monitor do that is because we don't know what the monitor is going to do. Change display settings is disruptive to the user experience, right? And furthermore, it doesn't really address the problem of if the user wanted to play in a window, which, maybe we want to support. Maybe we don't, but if we do, if they want to draw in a window, you're going to have this problem regardless because you can't call change display settings for the window. The window is however big the user stretched it, right? So that's what we'd like to do. Okay. So in order to do that aspect ratio stuff correctly, what we would like to do here is do exactly sort of that procedure. We have essentially two cases that we're dealing with, right? We are dealing with the case where the monitor has extra room on the top and bottom, in which case we need to fill those with blank space. And the other case is the sort of opposite of that, where the top and bottom fill just nicely. Oops. But the sides are missing, right? And so conceptually speaking, what we're doing is we're saying, okay, tell me how big the monitor is. We're going to start in here with a 16 by 9 rectangle, right? We're going to sort of expand the rectangle up until it hits either the monitor's, vertical edges or its horizontal edges. If it hits these horizontal edges first, then we know we would be filling here, right? If instead it hits these edges first, that's what would stop it from getting bigger. Then we would know we were filling there, right? So that's the fundamental math that we have to do. But once we do that math, then we kind of know exactly what we need. So what I'm going to do is I'm going to make a little piece of code here that is capable of determining this. I'm going to put it in the OpenGL side of things for the moment, although we'll probably want to pull it out into something that we can use elsewhere. Don't know. Well, we might have. Do we have some kind of a shared... We've got some shared things here. So in the shared code, I could just put it in here for the aspect ratio. I could also put it in render. That's probably the best place for it. I mean, it is a rendering only kind of a thing. So yeah, so let's say that we had something where we were going to specify this. And I guess I don't really need a separate type of return for it. I suppose I can just use a regular rectangle return for it. That seems reasonable. So I suppose I can just say, like, okay, I want to return a rectangle 2i that is the aspect ratio adjusted location, right? Aspect ratio fit, something like this. And so what I want to do is I want to say, all right, I've got a a render width and a render height that I'm dealing with. And then I have a window width and a window height that I'm dealing with. And I want you to do the necessary fitting to make those work out, right? Like I want you to sort of return me the rectangle I would use inside the window to draw what I'm trying to draw. So, since I said we had two cases, obviously, we have, and you know what I'm going to do here too? I'm going to just do a quick check to make sure if render width, I want everything to be greater than 0. Because there's really no result, and we're going to be doing some divides. So before we go any further, I just want to say everything's got to be, we're going to just return a 0 rect, a non-blit, basically, if you don't give us something to actually work with. So then I'm going to basically mirror those two cases. Like, you know, we have two cases, so I'm going to mirror those two cases. And by the way, I should add, there's obviously a third case here, which is it fits directly, right? But we don't really have to consider that case because either of these two cases will work in that if it happened to fit exactly, either case will work out to an exact rectangle that fills, right? So we don't have to, the reason I didn't explicitly enumerate that case is because we won't actually do that case. So what we need to know now is we need to know some fundamental ratios, right? We need to know what the aspect ratio is that we actually want, right? And then we need to see what will happen if we try to use the window at that aspect ratio, okay? So let me show you let me just sort of type in the code a little bit here, and we'll sort of talk about the equation then on the whiteboard, if that makes sense. So, in this case, I'm going to ask, if I took the render width, right, and divided it by the render height, okay, this would sort of give me a, I don't know what I would call it. It's a, it's sort of a fundamental multiplier, right, this aspect ratio. It's a fundamental multiplier that if you gave me another height, it would tell me what the height would be based on this ratio, right? So, you know, just trying to ground it a little bit for you here. If I take some width and I divide it by some height, right? Then what I do if I multiply by some other height here, right? If I'm going to multiply out by some other height here, is I cancel out the heights. And I'm left with a width that's in that new sort of space, if that makes sense. You can kind of think of these almost as units. Might be a good way to think of it, really. If I take, you know, x width over y height, right? And then I multiply it by, you know, a height, right? Then my heights cancel, right? and I'm left with, ax over y width. And that is the width that A would have implied, right? If it was at the same ratio as this original ratio. I'm trying to think of I feel like my brain's too mushy today for some reason. I feel like that's not a good enough explanation of this. What I'm trying to say is, once you produce an aspect ratio, right? So once I have width over height, once I have an aspect ratio, you can think of this as a fundamental constant that allows me to generate other widths, whatever the numerator is. It allows me to generate other widths that are in the same proportion to some heights as this width was to this height, right? So if I have width 0 over height 0, and I want to know what width 1 would be, like what is width 1 if I know h1, then the answer is I just have to multiply it by this fundamental aspect ratio, right? Because width 1 over height 1, right? We're saying if it equals, if I want the aspect ratios of these two to be equal, right? Then you can see if I solved for width 1, I would end up with width 1 equals width 0 times height 1 over height 0. You can isolate that term, right? And say that that's width 0 over height 0 times height 1, right? And that's exactly the term I was talking about before. So if you want to set up a bunch of fundamental similarities there, or if you're thinking in terms of them, it just helps to go, oh, right. Once I compute one of these, I can always multiply by whatever the type of thing was on the denominator to produce an arbitrary numerator that goes with it, right? So, and it's because of this fundamental relation that two things over each other, when I equate them, I know I can always multiply out one way or the other. I can solve for W0 or solve for W1 and, compute one in terms of the other, right? So that's what I want to do here. I want to do exactly that equation. Like, here's that fundamental thing that I produced, and what I want to do here is say, okay, I am going to ask if I was to multiply the window height by this fundamental aspect ratio for my render, what do I actually get back as like the optimal window width, right? And then by the same token, I could ask what the optimal window height is by applying the same logic. If I was to take the window width and multiply it by the same exact thing, just flipped around, right? You can see I'm doing the same thing. I'm just saying, okay, I want to produce widths now, so do the opposite thing, keep width on the divide. So when I multiply out, I'll get whatever the height should be. So this gives me two fundamental values back that are telling me what would the window width be and what would the window height be if I was to pick one or the other as predominant, right? Now you may ask, why am I doing that? Well, the answer is because this is what will allow me to determine which case I have, right? So in this case, I can say, let's see what we got when we said what the optimal window width was, right? So I used the given window height and I said, tell me what the optimal window width was. Well, if the optimal window width is greater than the actual window width, right? What I have to work with, then I know that I must be bounded by that width, right? In other words, I would have hit the width first before the height would have hit. Otherwise, I can assume the opposite, right? I can assume that if the width would fit, then that means the height is actually the thing that stopped it, right? So in this case, if it's greater, if the optimal window width is greater than the window width, and maybe well, no, I think that's right with it. So this is a width constrained display, and this is a height constrained display. And so if it's height constrained, then I have left and right black bars. And if it's a width constrained, right, then I've got top and bottom. If that makes sense. Okay. So let's think about what ends up happening here. I want to produce a rectangle 2i. That rectangle 2i is what I'm going to use to sort of like fill the screen properly or whatever, right? I need to like I need to like say where the image is going to be centered or whatever. So in a width constrained display, where I've got top and bottom black bars, that means that I know that my result is going to have a very simple structure as far, and you know what, I don't really even remember what our rectangle 2i structure looks like. There it is. So I know that since we have top and bottom black bars, I know the min x is going to be 0 and the max x is going to be the window width, right? I know that I'm filling my entire width. But what I don't know is what the min y and max y are, because I don't know where, the image ends up getting centered. But I can easily find out. So what we have is empty space, right? I know what, when I did the optimal window width here, I know that it didn't fit. So I know that optimal window height is going to tell me, if I was to assume we were width constrained, because that's what I was doing here, right? I said figure out what the window height would be if we're going to stretch to the full width of the screen. Whatever the window height is, that's going to leave some space. So if I take the actual window height and subtract the two, I will get however much space is left over, right? Hopefully that makes some sense. Now, we have a problem here, which is the optimal window height may actually not be rounded, if that makes sense, right? We may have a situation where the render width and render height were producing a divide that ends up with like a 0.5 in there or something, right? Or something that's not an integral amount. So we do have a bit of an issue there where we would, we kind of have to know that we're going to round, because this empty space may end up being not a whole value. So when we go half empty, and I divide that by 2 there, right? I now kind of have to round that value so that we won't be positioning on a completely bogus boundary, right? So I'm going to do a round here. Actually, okay. And similarly, I'm going to have to round how much we're using for our actual height. And so we might be off by like a half a pixel somewhere, but that's okay. We don't want to render to a fractional pixel, so that's fine. So now we're in a position to know what our min y and max y are. First of all, our max y obviously is always going to be just the min y plus however much the height was, so that's pretty easy. And the min y is just going to be that half empty value, right? However much empty space we had left over, we put half of it at the top, half of it at the bottom, right? Seems pretty straightforward. Okay, so barring bugs or logic errors, that's basically what we're doing. And the same thing is 100% true on the other axis as well, right? We can assume that if we are height constrained, we're going to draw to the entire height of the screen. We can also assume that, any place that we were talking about heights, we're now talking about widths, like so. And so then the rest of this is just a trivial replacement. Okay. So now we've got aspect ratio fit, and now we just have to use it. Well, we have to debug it, obviously, at some point, but we have to actually use it somewhere, because if we don't actually use it anywhere, then it's not going to actually do anything for us, to say the least. But the place that we probably want to use that is here in our OpenGL subsystem. And so in order to do that, when we pass the window width and window height here, what we really probably want to do is pass in that rectangle 2i, right? We probably want to actually do something more like this, where we say like, okay, what's the rectangle 2i that we're talking about here? That's going to be like the draw region or something like that, right? And so the interesting thing about that is once we do that draw region thing, then I think for GL viewport, we can actually just pass these directly. But I think since it's a width, and I don't actually know if we've got this call. We probably have a get dim. Well, I don't know if we do or not. I would like a get width and a get height on mine, so I'm going to add one of those. Yeah, we don't have one. So again, this is totally trivial, right? And I'm obeying the convention that we don't include the final row. That's why it's minus, that's why we don't add one here. So if the max and the min are coincident, that means it's an empty rectangle, not that it's a 1 pixel long rectangle. Just worth pointing out, because there's 2 conventions you could have followed there. All right. So, that's all well and good, and I think that would work at the start, but the problem we would have here is that viewport is not going to be correct for our frame buffers, because if our frame buffers just use the renderable part, they don't want to use this min x, min y, they want to use 0, 0 window. Like since the render buffers are only the size that we're actually rendering to, right? Oops. They want to do this, right, when we're drawing to them. So, when we bind a frame buffer here, you could imagine wanting to do that, essentially, and, we could do that down here, I suppose. You want something that looks like this for the targets that are greater than target 1. I guess since this is bound up here and this is only doing new ones, maybe that's the right place to do it. It's hard to say. Let's do it here. But the thing that I'm not sure about, and I tried to look this up yesterday and I failed, is GL viewport per frame buffer or not? Like, where is that state actually stored? Let's see. GL viewport. That doesn't help us. Stack Overflow, always a little scared to look at an answer here. So this says, okay, so this person looks like they actually quoted the spec, which is starting to contain tables of the entire state. State per frame buffer object, draw buffers and read buffer, viewport isn't part of it, right? So if that's the case, then if we want to support the multiple sizes, we've got to do it here. So we basically have to do our GL viewport call. Every time we bind. So I'm going to have to kind of abstract this, right? Okay. So in this case, we've got like GL bind frame buffer. If the target is greater than 0, we do this. Otherwise, we do that. Right? That's kind of how that has to go. And so what I could do here is just do a thing where we say like internal void bind frame buffer. And when we do that bind, I could just sort of grab this out like so, so that it's just used properly in both cases. So there's the target index. It'll just do this. And then we know that we have to pass the draw region to that, because without the draw region, it won't have the information that it actually needs to have, right? So that seems reasonable. And then down here, so when we do that, we'll just call OpenGL bind frame buffer with the current frame buffer and that draw region. Oops. And the same thing would be true up here. Let's see. OpenGL render commands is now taking this window width and window height, and we don't actually want it to do that. What we want to do is we want to have it take a rectangle 2i, which is the render region, right? And for now, I'm actually going to just pass it what we were passing it before, just so we can make sure that our render stuff works properly. Because anytime you're working with OpenGL, I find it's good to like double check when you test stuff, not just assume that it's going to work, right? So yeah. So anyway, that looks the same as it did before, so that's good. So now let's go into here and say, okay, instead of using that draw region, let's actually go ahead and try out this aspect ratio fit call that we had here. So instead of doing the stretch version, we'll call aspect ratio fit, and we will pass it our commands render width and commands render height, and then our window width and window height, and we'll let it figure it out what we want to do as far as that's concerned, right? What was... I don't actually remember... Oh, well, you know what? It should just be right here, shouldn't it? Commands width. So it's not render width, it's just width and height. Oops. Got a little overzealous there with that delete key. Didn't want to delete that. Let's undo. Okay. So now we're calling aspect ratio fit. And you can actually see that I guess we must have done a good job, because it looks like it just is working actually already. So you can kind of see what's happening here as we do that sort of scaling. As you know, here is the case where we're sort of well, I guess here is the case where we match, we exactly fill, right? And I guess I could find that here on the window size as well. Right? And so if I were to, and you can see that yellow band is like the actual border of the rendered region. As I start to smush inwards, you can see it adding the bars on the top and the bottom, because this aspect ratio is too tall for a 16 by 9, right? So it continues to kind of shrink that down and down and down, you know, which is what it's supposed to do. Now, similarly, if I stretch it out, it knows that it's going to hit on the other direction, so it just pads on the left and right, okay? Now, we're not doing this correctly here with let's see here, global render type, with respect to the software render at the moment, so we need to fix that. But that's pretty easy to do as well. All we have to do is, when we do OpenGL display bitmap, we just have to do the same thing we were doing before. So I'm going to go ahead and move this up to the top, like so, so that when we do our OpenGL display bitmap call, and we're passing it this window width and window height, instead of that, I'm actually going to pass it the draw region instead, right? So then if we go over to OpenGL display bitmap, which actually is not in there. Okay. So if we come over here to OpenGL display bitmap, and we do sort of this window width, window height part here, I'm going to take that out of here and just do rectangle 2i for draw region. And we're going to do exactly the same thing that we were doing before. Now, what I can do in this case, too, is I can just lean on the fact that this call doesn't actually care about whether you even have any other things. You can still use it as you were using it before. So if I want to, I can kind of come up here and just say, well, you know what? Just use OpenGL bind frame buffer and just bind frame buffer 0. And that'll set everything up for us exactly the way we want it to, right? So we can pass the draw region and we can pass frame buffer 0 and it'll just work. Now, in theory, let's see here, where we do platform controls. Let's see, there we go. Now you can see same exact thing. Right? Okay. So now we have a couple little tiny issues that we probably want to clear up. And that is, well, first of all, I suppose our clear color here, we're going to have to actually clear to something real, right? So we want this to be, you know, black, presumably, so that when we clear, let's see, rendering type true. So this way, you know, it's black bars, which is, I think, what we said we wanted. Although I suppose we could choose to do gray bars instead. I don't know what we want to do exactly with that. I suppose we could just clear to whatever the background color is from the render commands. That seems plausible. So when we do OpenGL display bitmap, we would probably just say, hey, give us the clear color, right? And then here we could pass the commands clear color. And now it's just whatever the user specified, which I think is what we want. And so let's go ahead and take a look at that. Platform, controls, little rendering type. Okay. Yeah, so I think that's about it. I also think that we should probably get rid of the outlining in our OpenGL stuff because that was, you know, not really part of the spec. And that's about it. So I think that's it for handling the aspect ratio stuff properly. I'm not 100% sure, but I think that's most of what that bug was talking about. So I believe we did that properly and we handled this properly. I think both of those are correct. I don't know what this is. Multiple OpenGL render targets. I don't really know what that's about. So I'm going to say that I believe this is fixed. And we'll let people say, reopen it if I didn't quite. Right? I guess I need a little more room here. How do I do that? Oh, there it is. It's called close issue. So I guess I can just say believed to be fixed on day 322. Right, so yeah, day 322 by the addition of aspect ratio aware, blitting, and rendering. Closing comment. Okay. So I think that's correct. Yeah. So we have, did anyone, is this it? Yeah. So while we're on it, I feel like we should do this one as well. And I guess we already have it open here somewhere. Where is it? There it is. We should do this one as well because we don't really have any awareness. The mouse cursor that we're passing is not adjusted for this, where the thing is actually being displayed, if that makes sense. So as long as they happen to coincide, they're going to be sort of okay. Although the stretching, even the stretching, we don't divide by the stretch at all either. So even that's wrong, because the distance you go will be wrong. So you can see it wrong there, right? So the only time this is correct is if you happen to be running on an actual 1920 by 1080 screen and you go in there, right? Now that's not actually our game code's fault. Our game code, I don't think anyway, I don't think our game code actually has a bug there, personally. The bug is in the platform layer, because the platform layer is giving us mouse coordinates that aren't in the same coordinates as where it's splitting the screen, right? We're drawing to a buffer, and we're assuming that when we get mouse coordinates from the game, that those mouse coordinates are in the same space as the buffer we're drawing. But that's not true, right? They're in the space of windows, which is totally unadjusted, right? So what we need to do here for our debug mouse, and again, it's only for debug because we don't really do anything with the mouse in production. We're a keyboard game, so we don't really have to care too much about this, but we might as well get it right. When we do our mouse values, you can see here we map screen to client, but then we don't have anything that actually maps from the client rectangle of our window to where we're actually displaying the bitmap. So we need to do that mapping now as well, right? And we should probably actually do a little bit of fussing with that too. But anyway, so if I wanted to fix that, obviously I'm going to have some way of remembering what that rectangle is that I used to draw, right? So that draw region that we have here, we're going to need to save that, basically, is what's going to happen, so that it can keep coming around, you know, and be something that we use in multiple circumstances, right? Now, I want to take a look at something here with window width and window height. Yeah, so we've got kind of this old path in here. I might even just get rid of this old path, to be honest with you. I don't know if I want to support displaying through GDI anymore, just because it's, you know, we're going to want to kind of go through the the vsync path anyway. So I may ditch this. I think that maybe we should. We can always put it back in if we really want it. So I'm going to instead say, instead of Win32 rendering type, I'm going to ditch this and say we just have B32 global software rendering. And then I'm going to go through here and say if global software rendering, then we're going to do this. Otherwise, we're going to do this. And in this case here, we're just going to assume that we display the bitmap. Oops. We're going to assume we display the bitmap through OpenGL, and we'll sort of get rid of the notion that we're ever going to stretch split it using anything else. Okay. Okay. So that's the first step, right? And hopefully now this still works fine for toggling our software render on and off. There we go. And global software rendering. What I would like to do now is just have the draw region be something that's actually passed in. Because now we got window width and window height, and you can see they're not really used anywhere in here. So what I'd like to do is I'd like to pull this out, and I'd like to go ahead and say we'll just pass the rectangle 2i of the draw region. We'll pass that in when we actually call Win3 display buffer in window, right? So down here now we will say, okay, here's our aspect ratio fit call. We've got these two variables which tell us what we're talking about dimension-wise, so there they are. And then I will say that this is the draw region. Okay, and so you can see what I'm kind of going for here. Now that I've kind of pulled this out into the outer area of the code, now we have the ability to just save this value all the time, right? This can be computed anywhere we want. We could compute it up before we do the mouse, right? So in the place where we actually grab that mouse cursor, right? When we do input processing, we can snap the region here, and now we know the draw region where we needed to know it. But where are my render commands? There we go. Well, okay. So do I actually have... I don't think there's any reason I can't move that up as well. There we go. So now if I just do that part early, so now I kind of know what is going on input processing wise. I can map things into this draw region if I need to. So when I actually do my mouse now, when I have my mouse X, I can map it into that region in terms of scaling, of mapping and scaling the value, right? So how do I map the value, right? Well, fortunately, in our math, we already have a way, and we've gone over this multiple times, right? Clamp 0 to 1 map to range. We have a way of forcing something in between two values into a 1 to 0 range. Right? So I can call whatever the mouse p comes back as, right? This new input mouse x, mouse y. What I could do is I could say, well, all right, let's say the new input mouse x and the new input mouse y. Let's actually make those be different things, and we'll sort of here start by taking these base mouse values, and then we'll sort of modify them, right? So I can do clamp 0, 1 map to range on mouse X and clamp 0, 1 map to range on mouse Y, and I can take those and map them into the min-max of the draw region, right? Because I know where the draw region is. Right? So what I'm basically doing is I'm saying I'm taking wherever my mouse was and I'm mapping it into that range. That's 0 to 1. I'm mapping it to be 0 to 1 based on where it is. So 0, 0 is the upper, the bottom left corner, and 1, 1 is the upper. So they're basically UV coordinates now, right? Then I can just multiply by the width and multiply by the height to blow them out to the pixel values, the virtual pixel values that the game is effectively expecting, right? Hopefully that makes some sense. And unfortunately, these are all not, there we go, not floats, and they need to be. Okay. So I can go over that during the Q&A if that was a little too abrupt in terms of what I did there. But you can see the mouse cursor is working okay. Now let's go ahead and change it to something really bizarre and make sure that the mouse cursor still does work okay, although it doesn't look like it is. So I may have some debugging to do here. That's plainly bizarre. What did I mess up? The mouse X is the mouse P. And draw region dot minx max y. That feels like it should be right. And then we expand that by however much the width was. Oh, I'm sorry. It should not be the width of the draw region. It should be the renderable width, obviously. I mean, we're trying to pass it to the game in terms of its preferred render size. So, duh. It's like I undid the divide I did in the clamp map to range. That makes no sense. Sorry, just momentary brain lapse there. Okay, so here we are in the normal case. Let's go back to the window case. And I'm still fail. I am still fail. What did I mess up? I have to admit, I don't immediately know what I messed up there. Well, I'm going to step in. I realize we're supposed to be in the Q&A right now, but I'm stepping in anyway. Because I want to debug this. I don't think it should be so complicated as I apparently just made it. And you know what else I'll do here? So this way you can see it. Yeah. Okay. So let's go ahead and step in there. Well, actually, let's not step in yet because it works properly at full screen. So I need to first sort of get the window to the point where it doesn't work anymore. There we go. So we can kind of see, like, it's like I'm at the top right now, which doesn't make a whole lot of sense, right? So, you know, this should be the bottom corner. This should be, like, basically 0, 0, right? So let's go ahead and see what we actually get there. So our mouse V is just totally wrong. Mouse Y, draw region, min Y, draw region, max Y. So why is the... Oh, because this is an incorrect... I didn't even look at the calculation we were doing. This is totally bogus right here. So that is probably the problem. So yeah, this mouse P, this whole thing with the global back buffer height, that shouldn't be the global back buffer height. That should be the actual, like the actual size of the window, right? That should be the dimension part. That should be this, right? So that's just a completely wrong calculation. It's inverting the mouse coordinate based on a totally wrong value. So that's, yeah, well, that's probably the entire problem. That would certainly do it. All right. So now our mouse coordinates are being passed correctly, and it looks like everything is hunky-dory there. Looks really accurate to me. We can switch here. Okay. So now we can go ahead and go to the Q&A. Yeah. And that's, you know, I say this all the time, right? Because I've been asked this so many times. amount of time it takes to find a bug is always about where you're looking, right? Because like I was looking at these lines and going like, oh wait, but they look right. It's like, yeah, they were right. You know what I mean? Like it's like the part that I was scrutinizing, expecting to be wrong, was not the problem. It was this part here, and that's why it was so weird to see what was happening, right? Because you always have like these assumptions about what you were doing, and when those assumptions are wrong, that's what leads to more bug time. Not that that bug took, any time to find, but why it wasn't immediately obvious. So let's see. All right. So I think we didn't get to a lot of these, unfortunately, but that's okay. I mean, bugs sometimes take a while to find. So we've got some more to do. Maybe we'll do some more tomorrow. Some of these look a little bit simple. Some of them look a little more complicated. But let's see if we've got any Q&As. Cubic before today, I have a 16:9 monitor, and when I change the code to render at that resolution, both the UI picking and the collision detection for the player get all sorts of messed up, but I haven't tested that since you removed the free moving stuff. Okay. Hi, can you make it so that holding shift while resizing the window makes it just scale at the intended aspect ratio? Oh, do you mean like forcing the window itself to always be at that aspect ratio? What did somebody say? Hold on a second. Open. Got a lot of questions here. So holding the shift, let's pause the hold shift thing because I don't know if we'll have time for that at the moment. But let's see. You forgot to change use height to use width. Oh yeah, that's true. It doesn't affect the code at all, but it's nomenclature wrong. So thanks for that one. Two-parter, if that's okay, I'd like to start working on a homemade 3D game engine of my own. How much of what you have done here transfers over? Basically all the code besides the renderer. The renderer is totally not going to help you, right? But all the rest of the stuff makes sense. B, when do you define how long a second is in the game? How does the lighting work in regards to time? I'm going to have to go ahead and say I don't understand part B. Those seem to be two totally unrelated things. Lighting and time? Like the only... Yeah, I'm sorry. I don't think I understand. How would you suggest a younger developer to get into OpenGL and all of its useful extensions? Well, that's tough. So NVIDIA has some great presentations on AZDO, which tell you everything that you need to know. Let's see if they've got a good one here. Here we go. So here's a thing where I assume this is kind of because the OpenGL NVIDIA team's like, hey, you know, you don't really need to use Vulkan because we got all that stuff in OpenGL already if you just use it. This page basically tells you all the stuff. The problem is if you're a younger developer and don't have a lot of experience, you're going to read it and go like, I have no idea what they're talking about, right? So I don't know how you get to the point where you can read and understand this page, but if you can read and understand this page, this tells you all the stuff you needed to know, right? Because it's got it all on here. In particular, pay attention to this. This one's a big one. Our buffer storage is probably one of the coolest things ever. It's like what you want. It's great. It's like it's about time, I guess is what I would say. But yeah, so in terms of what the useful extensions are, they're kind of all listed here with pointers to where to read more about them. But how you get to the point where you know what this is talking about, I think you kind of have to just go do some basic OpenGL programming instead, right? Did you ever go through the Nsight plugin on stream? No, I can't, I don't think, because this is an AMD card. I don't even think it, I don't know if Nsight even works on AMD. It might. I've never tried it, but I don't know we can use that. Off topic, which keyboard layout do you use? I just use standard QWERTY. Have you tried the various layouts? I've read that QWERTY can be a bit less efficient for programming. What do you think? I don't think it probably would matter that much, to be honest. You know, I type pretty fast on QWERTY. I don't know that I could... I mean, maybe a better keyboard layout would get me an extra 20% or something, but I don't know that that's enough to relearn. And anyway, if you have experience in OpenGL but not with the extensions, then yeah, I'd start with this page and then go read about all the extensions they talk about, right? Okay, and like they have, like here's a presentation, GDC presentation they did at one of their sponsored sessions or something, right? You could watch this and hear what they have to say. You know, so AZDO as a search term, I think, is what you're looking for, and that should unlock a lot of hits for you, right? And so let's take a look at the question someone asked, where holding the shift key down would constrain the excuse me, would constrain the size of the window. Yeah, so I'd have to think about that. I'm not sure what the most correct way to do that is. So yeah. I'm interested to see if Raymond Chen has a specific thing where he says the best way to tell Windows the size, but it doesn't look that way. Let's see. So it looks like he is suggesting we do it on get min max info. It looks like. So I think it looks like we only have to handle that, maybe. He seems to think that should be sufficient, I think. So let's give it a shot. And I said this before when we did full screen. I'll just say it again in case you didn't watch the full screen episode. Whenever I want to do something that has to do with like a sort of tweaky Windows thing, I always try to double check to see if Raymond Chen has said the right way to do it. Because he is the master of tweaky Windows things, and he has access to the source code, which I don't. So when he says, this is probably the most efficient or least error prone, really, is usually the thing, way to tell Windows to do something, I always start with whatever he says, because I find it's usually the most likely thing to just work. So if we want to handle get min-max info, it says that the L param points to the min-max info structure, but I don't actually know what it's even going to fill out in here. I assume it's max position that it cares about. Let's see. The maximum tracking size, the largest window size can be reduced by using the border size of the window. The minimum tracking size, the smallest window size can be reduced by using the border size of the window. Well, see, that might work for what he was saying to do, but that's not going to work for what we are saying to do, is it? Because he just wanted to force it to only size in one direction, and that's not going to work here. So yeah. Let's see. So looking at this, this might be better. Let's see. Okay, window post training message def window proxy. An application could override these defaults. While this message is being processed, modifying any of the windows affects the window's new size position or place in the Z order. An application can prevent changes to the window by clearing the post. Okay, so it sounds like what we could do, right, is we could intercept this message. So we know when we are going to have our size changed, right? And we could say when our window post size is changing, we have the L param in this case. Process pending messages. Is there a reason we are... Where's our wind proc? I want this in the wind proc. There we go. So this L param in theory is a pointer to one of these things, window pose. And then what I can do is just, I'm going to pass that message through to the existing Windows procedure. Right. So in theory, if we just do this, we should have, no change. Now, if we have Windows pose changing and we want to modify this pose, then in theory we should be able to just reach into it and change the actual CX and CY values, which are the width and the height. So what we could do here is say, let's just force the aspect ratio to be correct. So whichever one got changed, we'll use the corresponding one probably, or maybe we could just do the closest one. I'm trying to think of what the best way to do this would be. So I think what I feel like we should do is say like window rect equals get window rect. And we'll just say like tell us how big our window currently is. We'll then look at which change was bigger. So we'll say like if maybe the absolute value. Do we have an absolute value function for this? I don't even know. If the absolute value of cx minus the width, right? Just compute the width that the window was before. Right, so it's like this is the width and height we were before. The new pose has what they will be. I guess I could do get window pose. Could I? Is there such a thing? Apparently not. Of course there's not. There's a set window pose, but not a get window pose. I mean, let's not be ridiculous here, people. Hilarious. Anyway, so let's take a look and see is the absolute value of the width change bigger than the height change? Hear me. So if the width change is bigger than the height change, we'll recompute the height. If the height change is bigger than the width change, we'll recompute the width, right? So in this case, we'll say the new pose cy. In this case, we'll say the new pose cx. And so if we want to recompute the height, excuse me, if we want to recompute the height from the width, then what we would need to do is say, well, the new pose cx is the divisor, right? And what we want to do is take our desired, like our render width, which I guess I don't know that we've actually really have at this point. So we'll sort of say we have it temporarily. Oh wait, I take it back. We actually do. Right, there's global back buffer. Right? So, need some more water. So I actually do have that, right? If I, oops. If I want to, I can say, here's my render width. Oops. Render width. Here's my render height. And so I want to recompute whatever the cy would be from the cx. So what I want to do here is again sort of solve that that fundamental proportion. So I want to multiply the render height, right? Let me get this out here for you. Right, I've got the render height and the render width. I want to solve for the new window height. So I'm looking for this right here in this case. So if I multiply out, and I mean, I guess I could just flip these proportions, right? I could just flip them around. So I could just say HR over WR equals HW over WW, right? And I want to solve for this right, I want to solve for this right here. So I just get HR WW over WR, right? So that is my my render width, right? Times my render height. My render height times my, which is this, times the window width that I'm getting, divided by the render width that I wanted. So that maintains the aspect ratio, render height over render width, and that should give me back the value that I wanted. Similarly, I can do the exact same thing oppositely for the computation that preserves the height and resolves for the width. Right? And so in theory, that would work, right? I think. So I've never really tried to do this before. So I'm not sure if it actually works or not. It looks like it sort of works. It's a little janky. So not quite right, but close, right? So one thing you said is it's got to have the shift key down. That's pretty easy. We can start with that, but then we got to address the other things. So get async key state, or I guess just get key state because we want it to be synchronous in this case. So we want to do get key state with the virtual key of vk shift. In other words, is the shift key down, right? And the higher order bit is whether it's down or not, right? And it's a short that's coming back, so it's going to be it basically, is it negative, right? It's basically like that. So now when I scale, it should be normal, but if I hold down the shift key, it's aspect ratio constrained. So we've got some kind of a bug here that I'll have to look at in a second. But let me just go ahead and point out one more thing first. So there's two things we have to do. One is we have to debug why we're getting that weird jitter there. But the other thing that we have to do is this is unfortunately setting the client. Setting the window rectangle, right? But we don't actually care what the window rectangle's aspect ratio is. We care what the visible region is, right? And so since we're trying to adjust the visible region, that is an extra part of the computation that we have to figure out, if that makes sense. So yeah, so let's start by just asking wm get or I want to know, is size changing, or sorry, window post changing, window post changing. I'm assuming that that's the window. Its part there. There's thick frame. The definite proc function sends a given the window. There's an eval the new side position window to enforce byte align client and byte align window. But not passing much change, much different from response. While the minutes being processed, modifying the values, placed in Z order, and application can prevent changes to windows by creating flags. So that's fine. See what window post says here. The window width in pixels, but it says C and C. I don't know why there's a C in front of it. I guess that just means the width. I'm not sure. But what I don't know is that the client size or the total window size? And I'm not sure. Of course, it's not documented because why would it be? You know, why would that be something you'd want to document? Like what the value is at all? The window width in pixels. I assume it's just the... I assume that it's just what comes back. So let's try this. I'm going to set a breakpoint in there, and I just want to see what it says there, right? I just want to take a look at that code. So I'm not going to resize it at all. I'm just going to click there. Right? So now what we should see, in theory, is our window rect and our new pose should be like the same thing. Right? And hey, guess what? It looks like CX and CY are actually the client rect. Honestly, that's way better for us. Wish you documented that. That would have saved us some time, but all right. Whatevs. That makes it a lot easier for us, so good on you, Windows, for picking the right one of those to do. All right. So we still got some weird stuff happening there that I'm not sure. All right. So when I fuss with this, let's see here. It's kind of having a beat frequency back and forth. It's almost like it passes the window pose changing twice, once with the window width and once with the client width or something. But I'm not sure. So I don't really see exactly what's going on here. I want to know if it's me who's causing that flicker by something wrong in the way that I'm doing the code here. I wonder if what happens is it then calls me back or something. I don't think it should. Yeah, I'm not sure about that. That's really weird. I'm not sure what's going on there. This isn't something I've done before, so it's a Windows thing, so obviously it's going to be tweaky and weird, but I'm just not sure I understand exactly why. I'm going to print out something here to the log, just so I can see. So I'm going to say, like, okay, the old one was width and height, and the new one CX CY. Okay. And I kind of want to, I want another thing in here, so I guess I'll do, excuse me. I want to print out the modification as well. So I want to do like old, new, requested, right? So here's the ones that it was doing so that I can put them in here. And now I can go ahead and say output debug string. So at least now I can kind of see a stream of information about this when it's happening. So let's see. The old was 571, 459. It's requesting 587, 498. So then it decided to use the 498, which made it go up to 885, right? Then it had 869, 460. I guess that's just kind of because the position of the mouse cursor. Oh, yeah. So the problem is the mouse cursor won't snap out anywhere else. So I can't just look at the delta. I guess I have to look at whatever is closest, right? I have to look at, like, what would be the closest aspect ratio window that would fit. I mean, that seems to me like what I would have to do. So it seems to me like I'd have to do this. So I can compute the new CX and I can compute the new CY, right? From whatever the request is. And then I guess I could just see which one causes the least change. Like which one is the closest, right? So basically, like, you know, is the new CY minus the CY, oops. So if the new CX is closer than the new CY would be, then use it. And if the new CY is closer, then use it, right? So we're not using the delta anymore. We're just using sort of the absolute, and we're going to see if that helps. Yeah. All right. So that's good, but we still end up with bars here, which I assume are because it actually is still like that it is actually giving us back window positions, maybe, not client positions, somehow, or something like a client position. I'm not sure, but something's a little weird. So I want to know, I would like to know, do I have a sprintf here? Is this the one that's like always complains about like what we're passing it and stuff? All right. So what I'd like to do here is say, well, what was the aspect ratio that I'm passing in, just to see if it's a valid aspect ratio, right? So I want, the aspect ratio I want is the render width over the render height. And the aspect ratio I got is whatever the new width of the window is here, right? And so it seems like we're getting basically the aspect ratio that we ask for. So it looks like that is not really the client area, and that it must be actually, it is actually the Windows rectangle area, right? So adjust, if I remember correctly, adjust window rect doesn't work. Adjust window rect in that way that nothing that Microsoft does ever works. Adjust window rect doesn't actually work if your window is an overlapped window, which ours is, which is awesome, right? You have to specify like other styles. I don't understand how that's plausible. But that's, we don't even, I don't think, have to rely on that really. I don't think. Because we can figure out the adjustment factor, I believe, right? So we can figure out the adjustment factor for the aspect ratio just by looking at what the difference would be at that position. And it's a little bit janky, but what I could do is say, well, I've got the window rect and the client rect, right? I get both of those. So I know that sort of my, my width add and my height add are going to be proportional to that. So the window rect right minus the window rect left minus the client rect right minus the client rect left is the amount of additional width that we would get. And similarly, I can do the same thing for the height, right? So I know it's going to pad those like additional values on there, right? So what I want to do here is I want to solve for this ratio now in that way. So what I know is going to happen is I have a client rect. So I've got a height client over a width client, and I want that to equal the height render over the width render, right? This is what I'm trying to do, if this makes sense. But the height of the client is actually the height of the window minus the height additional, right? Whatever that is. And the width of the client equals the width of the window minus the width additional. If that makes sense. So if we are trying to make this be true, then essentially what we have here, I guess, is we've got HW minus HA over WW minus WA equals HR over WR, right? So if we want to actually make these equations work, we have to multiply by these giant terms here. So we have to say HR WW minus WA over WR, and then we have to, So we actually have to compute that, I guess, if we want to know what the height of the window is actually supposed to be, right? So anyway, so that means that if we were going to do that, so let's do the width here. So the new CY is going to be equal to the render height times the quantity window width, which is this, minus the window additional amount, right? Divided by the render width, which we are doing. Right, render height is it divided by the render width plus whatever the HA value is there. And I'd like to do that on the top. So I'd like to do that like this, because this is actually an integer divide. So I have to multiply it by WR, right? Because it was HA, so I have to multiply by WR over WR to give me WR HA over WR. So it's actually the quantity times itself times the render width there and the height add. Right? So there's that monstrosity there. And then for the CX, everything is flipped, right? So this is the width, this is the Y, this is the height, this is the width, the height. And one crosses one's fingers. So let's hope that some of that was right. I don't know if it was. Doesn't look like it, unfortunately. I guess we could have a bug in the other part of our code. Like, let's see what the client rectangle actually is. So if I take the client rect bottom, well, client width and client height, so if I actually just do client width over client height, we can see what we were actually getting. No, so it's definitely wrong. No question about that. So let's see. That is the new window width. Did I do this right? I may have messed up this math. We wanted the client to be equal to the render, and we said the client was the width minus the added amount, right? In both cases. So that seems right. Now, there's another way we could have computed this, I suppose. We could have subtracted in and then added it back. Meaning we could do something like this. This might be a clearer way to debug it, right? We would say that the new one is the render width times yeah, essentially exactly that, but without the plus, without this, right? That's a little bit easier to see, right? So you're basically saying, well, let's solve for the client, and then we'll put it in there, right? So that's all messed up. Oh, pff. Oh, that's great. I never changed this to get window rect. So those would have all been 0. Gosh, I wonder why we weren't seeing any change there. There we go. Now it's perfect. Okay. So I think that's all good now. So yeah. Who asked that question? I know somebody did somewhere. Okay, hi, there you go. Does that help? Okay. Well, I'm going to go ahead and wrap it up. And yeah, for adjust window rect, you can pass a set of flags that is equivalent to WS overlapped, and then it will work, I think, but maybe not. So. All right. Thank you, everyone, for joining me for another episode of Handmade Hero. It's been a pleasure coding with you, as always. If you would like to follow along with the series at home, you can always pre-order the game on handmadehero.org, and it comes with the source code, so you can follow along at home. We also have a forum site you can go to if you want to ask questions, a Patreon page you can subscribe to if you want to support our video series, a schedule bot that you can follow if you want to know when we're going to be live, and an episode guide if you're trying to catch up on old materials. That's about it for today. I'll be back here tomorrow for the last stream of the week, 5 p.m. Pacific Daylight Time. Until then, have fun programming, everyone, and I will see you guys on the internet. Take it easy.